Morning students, we are with a new video about the electric current in the conductor. That means, what is the mechanism of flow of current in the conductor? We know that every matter is made up of what? Atoms and molecules. In conductors, what will happen in conductors? Atoms are closely packed. So the valence electrons are no longer be attached. So the valence electrons are no longer being attached firmly to the individual atoms. Is it clear? These electrons are not firmly to the individual atom. And hence they can move. They are known as what? Free electrons. We cannot know which one is the electrons of which atoms, and they are because they are packed in a small packets and they are having what? In a large number. So here we cannot decide which one is free and which electron is attached to which atom. So in this case, what we will do, when no electric field is applied, they will what? Due to the temperature, this free electron will, due to temperature which is arising between them, that is known as thermal agitation, they will move randomly in all directions. Is it clear? They will move randomly in all directions and collide with their ions. Hence, the total they will move randomly with same speed, but directed in different directions. So they will have different velocities. But due to this due to the absence of any electric field, they will not come out from the atom, and due to the absence, due to their collision with ions, their resultant velocity will become zero. So, if we consider there are n numbers of electrons are there whose velocities are v1, v2, sorry, u1, u2, u3 vectors up to un are there, the net velocity will be how much? U average equal to how much? U average equal to u1 plus u2 plus what? Un divided by n equal to 0. So n equal to 0. So their net velocity is considered to be 0. Is it clear? Now, if we give some electric field, then what will happen? How we can give electric field? Suppose we have connected this end with a positive potential, with a battery having positive potential, and this is connected with a negative potential. Then what will happen? All the electrons from this matter will try to move towards the positive terminal of the cell. That is, all the electrons will move against the direction of applied electric field. For that, what will happen? As the electrons will move opposite to the direction of applied electric field, they will acquire some velocity. But still, again, they will collide with their, suppose this electron will collide with another one, they will collide among themselves, and they will have their velocity, they will come to its original, their velocity will increase for some time, very small interval of time, their velocity will increase. And the common velocity with which they are coming towards this positive terminal, that means against the direction of applied electric field, is known as drift velocity. Suppose after getting this electric field, that the velocities of each electron become v1, v2, up to vn. This velocity they have acquired, and which is for this very small interval of time. So we can get the average velocity v average equal to how much? v1 vector plus v2 vector plus v3 vector plus vn divided by n. But here you cannot say this is equal to 0 because it is connected to the source, so they will have that velocity. They will continuously, this velocity will be there. And that average velocity is known as what? Drift velocity, isn't it? Now we are going to find out the expression for drift velocity. Generally it is denoted by V suffix D, drift velocity, isn't it? We are going to find out the expression for drift velocity. You see, we have a conductor, okay, whose length is L, and there are huge numbers of free electrons are there. We have connected this end of the conductor with the positive terminal of the cell having potential difference D, and this end with the negative terminals of the cell with potential difference D. Now these electrons will get a force. Okay, these electrons will get a force due to the electric field. What is that force? F vector is equal to minus of small e into capital E. Why minus e? Because it is the electron, charge is the electron, and generally this electric electron is negatively charged. If small m is the mass of electron, then F vector is equal to small m into capital A vector. Now equalizing these two, we will get what? Ma vector is equal to small e capital E vector, implies A vector equal to minus of small e into capital E divided by m. That is the expression for acceleration. That common acceleration they are acquiring, by which they are moving from one end to another end. And its magnitude is given by A vector is equal to small e capital E divided by m. Now you see, we have the equation V equal to U plus AT. Here the different electrons will acquire different velocities in a very small interval of time. So their acceleration remains constant, but the velocity will change due to the direction. So V1 vector equal to U1 vector A vector tau 1. V2 vector equal to U2 vector plus A vector tau 2. In this way, Vn vector equal to Un vector plus A vector tau 1. Now the average of this one, that means if I say this is the common drift velocity, V suffix D is equal to V1 vector plus V2 vector plus dot up to Vn. So it implies if we put the value of V1, it will be how much? U1 vector plus A into tau 1 plus U2 plus A into tau 2 dot up to Un vector plus A into tau n. Now if we separate these two, then what we will get? We will get U1 vector plus U2 vector plus dot up to Un divided by n plus A vector into tau 1 plus tau 2 plus divided tau 1 divided by n. As we know, initially the initial average velocity of the initial, when there is no when there is no potential difference connected between them, then it is 0. So 0 plus A vector tau is where tau is the relaxation time, average relaxation time. Okay, what is relaxation time? It is the time between two collisions. When the electrons move from one point to another point inside the conductor, there is a collision among themselves, and the collision among any of the two conductors is any of the two electrons is known as relaxation time, and the average of this relaxation time is known as average relaxation time, which is given by tau. Now we get the expression for Vd is equal to how much? A tau. Now you know the value of A is what? Small e capital E divided by m. So Vd equal to small e capital E tau divided by m. Again, E equal to V by L. We know that electric intensity is the potential by L. So Vd is equal to small e capital E V capital tau divided by m into L. So this is the expression for drift velocity. Clear? This is the expression for drift velocity. Please go through the video. Okay. Now we are going to find out the relation between electric current and drift velocity. We are going to find out what? Relation between electric current and drift velocity, which is also very important. Clear?